Hello ladies and gentlemen, boys and girls. My name is Mr. Do and science is my business. You're welcome to Mr. Do Science World, and today we'll be looking at calculus, but the aspect of calculus that we are going into is to look at the product rule and the quotient rule. So let us begin by looking at the product rule. Let's assume that we have a function, and this function is, say, y equals to certain function, and this which is in terms of x, and this function can also be expressed in terms of two different functions, such that each of these functions are also in terms of x. That simply means that the product of the function will simply be expressed as y is equals to what, say, uv or vu. Now this means there are two functions, and these two functions are combined together and they are given as what? Just one function. So this one function can be expressed in terms of two functions, and each of these are also in terms of what? In terms of x. Let's look at it. These can just simply be like, say I write like y is now a function of, say, x, okay? Right. So that we have something like f of x being multiplied by, say, v of what, g of also x. So this is a function, this is a function, and once this happens, it means that we can easily just write that function as a common function of this, where I am using, say, the u to represent f of x, and the v is now representing what? The g of x. Whenever we have any problem like this, how do we go by it? Okay, according to the first video that we did, what you can do, we can simply multiply the two binomials together, and then after multiplying the binomials together, you simplify them, and then you take the derivative of the function. That is one way to do that, but sometimes it becomes complicated if the binomials has a higher power or a higher exponent. So we're going to look for a simple way in which we can what? We can take the derivative of such what? Such functions. So this is the product rule. The product rule says if you have anything like this, we can just simply say that, okay, our u is being represented by f of x, okay, and then our v is being represented by, say, g of x, such that from here we can take the derivative of this particular one and say y prime of x should now become what? It will become u multiplied by the derivative of g of x, okay? That is u multiplied by the derivative of what? V, plus what? V multiplied by the derivative of what? The derivative of u. Now remember that each of these is in what? Is a function of x. It's a function of x. So this is what we refer to as the product rule. And remember, I told you, if you have anything like this in the first video, we can simply write this as what? F prime of x, okay, being equal to u the v the x plus what? V du the x. And this is what we refer to as what? The product rule. And this is what we are going to apply in solving problems. So let's begin with some examples. Let us apply this rule and see how we make use of this rule. Example number 1. All right, now let's look at the example that we are given here. The first example says, find the derivative of the function y equals to, into bracket, x squared plus 3x into 2x minus 1 by 1, expanding the binomial and differentiating term by term. 2 by what? Using the product rule. Alright, one thing we have to understand is the question 1 and the question 2, we should have the same answer. Either you are expanding and you are differentiating a term by term, or you're using the product rule, in either case, we are looking for the derivative, and therefore, we should have the same answer. So let's begin by expanding them term by term. Right. So, straight away, I just need to write down the function that I was given, and this is the function. So I need to expand this by multiplying the what? The binomials. So if I'm going to do that, I multiply this by that, multiply this by this, multiply this by that, and multiply this by that. And then I'll simplify. So when I multiply this by this, I am having 2x cubed. Okay? And I need to multiply this by that again. And then I am going to have x squared. And I multiply this by that, I'm having 6x squared. And I multiply this by that. And what am I having? I'm going to have 3x. Sorry, negative, because this is positive here. So negative 3x. And once I've gotten this, I need to simplify because they are like terms. These and these are like terms. So I'm going to simplify. And to simplify, this will give me 2x cubed, okay, plus 5x squared minus what? 3x. So this has become the function that I was given. This now is the function that we need to take the derivative of. After we have gotten this, okay, I can just say now that, okay, y prime of my x, or f prime of x, is now equals to what? Taking the derivative, this will go there, so I will have 6x squared plus this multiplied that, this gives me 10x, and then remember this will give you what? Negative 3. This is now the derivative of the function that we were given. If we were to go by the binomial, this is exactly, by expanding the binomials, this is what we're going to have. So this is the response to question number 1. Now let's look at question number 2, where we are solving the same problem again, but this time around we are told that we need to use specifically the what? The product rule. So let's look at how we can apply the product rule here. To apply the product rule, first thing is for me to know the function that I was given. This is the function. So I'm using this as my u and I'm using this as my v. Once I have taken note of that, my u and my v, now I need to take the derivative of each of them because this is a function. U is a function in terms of x, v is a function in terms of x. So I need to take the derivative of each of these functions. So I'm going to find du, the x. That means I'm differentiating u with respect to x. And here this gives me 2x plus 3. That has become the derivative of u. Now let me find the derivative of v. That becomes the v, the x. And the v, the x here is also going to be what? 2. I have gotten each of them, their derivative, each of the functions, the derivative of each of the functions. But now we want to apply product rule. So what is the product rule? The product rule is simply what? The y, the x is now being equals to u, the v, the x, plus v du, the x. Okay, so now I know this is my formula. I need to go. I know the terms u is here. I know v is here. I know the u, the x is here. And I know the v, the x is also here. So I can just simply go do the substitutions and then simplify that now. So let's go on. The y, the x. The y, the x is now equals to, where is u? U is here. And u is x squared plus 3x. Multiply by what? The v, the x. Where is the v, the x? The v, the x is here, it is 2. So that is multiplied by 2. There is an addition sign, so I put down the addition sign. And now I have v. Where is v? It is here. and v is 2x minus 1. Okay, multiplied by what? Multiplied by du the x. Where is du the x? Du the x is here, and that is also what? 2x plus 3. Now let's simplify and finish up from here. So once I am here, I multiply this by that, and I have 2x squared, and this will be 6x. And from here, this multiply this will give you 4x squared. This multiply that will give you what? Will give us 6x, and this multiply that negative 2x and negative 3. So now we need to collect like terms. There is 2x squared plus 4x squared here, giving you what? 6x squared. And there is 6x, there is 6x, and there is what? Negative 2x. 6x plus 6x will be 12x minus 2x will give us what? Positive 10x. And now there is what? There is 3. So we can see we are getting back the same answer as the one when we were solving for what? By expanding them. So either we use the product rule, or we are going to make use of what? The expansion rule, where we expand and take the derivative of each of the functions what? Term by term, and that we're going to get the same what? The same answer. Let's look at example number 2. Okay, so let's look at example number 2. Given y equals to x squared sine x, find the y dx. So if I'm to find the y dx by here, the first thing we need to do is try and see what we are given. We can see this is a function and this is a function. So we can just simply say that y is now f of x multiplied by what? G of x. And if that is true, then by the product rule, we're going to have something like this by the product rule to say the y dx is now going to be something like f of x multiplied by g prime of x plus g of x multiplied by f prime of x. If I go by the functional notation, this is what we're going to have, which is just the same as the product rule that we have. So from here, this is my f. I need to take the derivative of this. I'm going to add it to this function multiplied by the derivative of this function as well. So let's see, what is my f of x? Let my f of x be x squared, and let my g of x be what? Be sine x. Okay. Once I have this, I can then find what? F prime of x. And what is my f prime of x? My f prime of x in this case is going to be what? 2x. And what is going to be your g prime of x? My g prime of x, remember this is a trig function and there's a sign. So if you take the derivative of that, we should have what? Positive cos. So that's going to give us what? Cos x. Now that I've gotten this, I can go back into this, substitute that, and see what I'm going to have. So the y, the x, is now going to be f of x. Where is f of x? F of x, we said it is what? X squared. Multiply it by what? G of x. Where is g of x? It is what? It is cos x. Plus, what is the next thing? G of x. What is g of x? G of x is sine x. So this is sine x. Multiplied by what? Multiplied by our f prime of x. The derivative of f. And what is the derivative of f? It is what? 2x. So this is 2x. Now this is what we will have. So finally, I can just simply say that this is just going to give me what? It's going to give us x squared cos x plus sine 2x what? Sine x. And this becomes the what? The function that we have. We can decide to factor out x. It doesn't matter. If you leave it this way, that's fine. If you factor out x so that you have x out and then x cos x plus what? Plus sine x, it's still okay. Right. So this is the derivative of the function that what we were given. Okay, so now let's begin to look at the quotient rule as well. Okay, so if you're talking about the quotient rule, let's assume that we have a function such as y is equals to f of x equals to, say, f of x over g of x. Okay, now, so we can see we are having a function y, and y is also equals to capital F, a function of capital F of x. Okay, which means that this capital F of x is just two functions which are in what? In a quotient form. Okay, they are just, we are seeing that there is what? There is a fraction, there is a numerator, and there is what? A denominator in this form. Whenever we see any function like this, then we can talk about the word, the quotient rule. Okay, so this is possible if it happens that, okay, we can find the what? The derivative of what? Of the f and g, if f and g are differentiable at x. That means we are saying that f and g are differentiable at x, and the value of the quotient can be what? Can be determined throughout the domain, or is defined throughout the domain at the what? At the value of x. Then we can say that what? We can apply what? The quotient rule here. So to apply the quotient rule, what then is the quotient rule itself? Alright, so now let's look at the quotient rule. State the quotient rule and see how we can now what? Express the quotient rule. So if I have the y, the x will now be equals to v du, the x minus u, the v, the x, all over v squared. And this is what we refer to as what? The quotient rule. So whenever we are given any function such as this, we can apply this in solving that particular word, function. Well, this does not mean that without this formula, you will not be able to what? To solve the function. Okay, so let's move ahead and see how to apply this particular formula here. Okay, so let's first look at some examples here. Problem to solve. Find each function. Okay, so for each of the functions, we should find its what? Derivatives by what? By the quotient rule and by another method. Okay, so the function number one given is g of x is equals to 5x minus 1 all over what? 3x squared. Right. Example 2 is giving h of x is equals to 1 over 2x minus 3. And number 3 is f of x is equals to 3x minus 2 all over 2x minus what? Minus 5. Right. Once we are given this type of functions, let's look at it. The first one is strictly by what? Quotient rule, which means that you have to solve by quotient rule. If you use any other method, there you are wrong, because the questions is stating it critically there that you should solve by what? By the quotient rule. The second one is to solve by another method. Another method could be any method. It could be the power rule, it could be the chain rule, it could be the quotient rule. But now remember, we have used the quotient rule here, so we can still solve here by the quotient rule. And then it could be any other method that you feel that you are convenient with or you are familiar with. So let's try and see how we will solve this. I am going to solve the first one here, which says we should use the quotient rule. So remember, with the quotient rule, I need to know specifically what my numerator is and what my denominator is. So in this case here, we know where the numerator is 5x minus 1, the denominator is 3x squared. So by the formula of the quotient rule, let me clean the board, write it somewhere, we go by that and then solve the problem all along. So by the quotient rule, we know that the quotient rule says the y, the x, is equals to v du, the the x, minus u, the v, the x, all over v squared. This is our quotient rule. So if this is the quotient rule, then we are going to apply that in solving this particular problem. So if I'm solving that, let's look at it. What is my v and what is my u? Okay, so look at it. Where is v? V is the denominator and u is the what? Is the numerator. Okay, so let's go ahead. My u is now 5x minus 1 and the v is now 3x squared. Let's find du dx. Du, the x is now going to be 5. And now let's find the v, the x. So the v, the x is now going to be what? 6x. Now I have gotten my u, I've gotten my v, I've gotten the u, the x, I've gotten what? The v, the x. It means all the what? The terms in the formula has been determined. What is left is to do what? To do substitution and do simplification as well. So let's go on. So straight away from here, I say that the y, the x is now equals to what? Equals to v. And what is v? V is 3x squared. Okay, multiplied by the u, the x. What is the u, the x? The u, the x is what? Is 5. Then minus sign, and then we have u, and u is 5x minus 1. Multiplied by the v, the x. And what is the v, the x? It is 6x. All over v squared. Where is v? So it is 3x squared, and there is a square there. This 3x squared is the v itself, which is here, and there is a square, so that is the square out there. Alright, let's do now simplification. If I go ahead from here, I multiply this by that, I'm having 15x squared. And now I need to expand this. So 6 times 5 there. So I have my 30, and then we multiply the negatives, this x, so we have x squared. Negative times negative there will give us what? Positive, and then multiply that by this. So what are we having? We are having a positive what? 6x. All over what? If we are going to square this, so I'll have this become what? 9x to the power of what? To the power of 4. And let's see if there are like terms. Yeah, there are like terms here. So I need to simplify. And if I simplify that, I am getting negative 15x squared plus 6x all over what? 9x to the power of this. Alright, from here, when you look at this, we can see that we can have a common factor in here. And once we have a common factor out there, we'll be able to solve by strictly doing that. What will be the common factor at the top there? We can have 3x out, so that this will become the y, the x will now become 3x out into negative 5x plus 2 divided by what? Here we can just take out 3x as well. So that will be left with what? 3x to the power of what? 3. This. So that if you multiply this together, we get back this. If you multiply this, we get back this. And once we do that, we know this and this will be out. And then finally, we are going to have the y, the x to be equals to negative 5x plus 2 all over 3x cubed. So this is the derivative of the function that we were given if we apply what? Our quotient rule. Alright, so the first one was to solve by the quotient rule, and this time around we want to use any other method. To use any other method, I have to look at the question critically and see which other method that I can use. So if I look at this, since this is a fraction, I can write it as g of x into 5x over 3x squared minus 1 over 3x squared. And when I have this, from here I can then see that, okay, this and this can be cancelled out. So I can write this again as 5 over 3x squared. Sorry, 3x, because one of the x is cancelled. Minus 1 over 3x squared. Now I'm going to write this as a power of exponent negative, or as a negative power, or negative exponent. So I can write this one as g of x is now equals to 5 over 3 x exponent negative 1. And this can also be written as the same as 1 over 3 x exponent negative 2. And now that I have seen this, I can see that, okay, I can apply the power rule. So that if I apply the power rule from here, I'll be able to solve that easily. So to apply the power rule, I'm going to have the y, the x is now going to give me this multiplied that, so I'm going to have negative 5 over 3 x exponent negative 2. And from here again, I'm multiplying this by that as well. So I should have positive 2 over 3, and then it's going to give me x to the power of what? Negative 3. When I have this, I need to now change the negative exponent into positive exponent. So by doing that, I'm going to have the y, the x to be equals to negative 5 over 3x squared. And this can also be written as 2 over 3x cubed. And when we see this, we can see that this is similar to, or is equivalent to, the first one that we got when we used the quotient rule. So how do I make it the same? Well, to make this look the same way, all I need to do is that, say the y, the x is now negative 5 over 3x squared is being multiplied by x. Okay, so it's like I've done nothing to the answer. X divided by x will give me 1. So I've done nothing to that by just multiplying that by this. It's the same thing. Plus what? 2 over 3x cubed. And what will this give me? This now boils down to give me the exact answer that we got when we make use of what? Of the quotient rule. So this multiplying this will give me what? Negative 5x over what? Over 3x cubed plus what? Plus 2 over 3x cubed, which is the same as just saying negative 5x plus 2 all over what? 3x cubed, which is the exact answer we got in the what? In the first one when we made use of what? The quotient rule. So this becomes the what? The answer. When we use the other method, or when we use the quotient rule, we should have what? The same answer. Alright, now this is question number 2. And the question 2a, we're solving by a, 2a, where we need to apply what? The quotient rule in solving the problem. So if I want to apply quotient rule, then I know that my v is now equals to 2x minus 3, and my u is 1. So what is dv dx? The v dx is now 2, and what is du the x? Well, remember, we are differentiating a constant, and when you differentiate a constant, what do you have? You have 0. So that is 0. Now that I have gotten 0, there I know all the terms in the formula. So let's quote my formula and do the substitution. So straight away, I have the y, the x is now equals to v. Where is v? V is 2x minus 3 multiplied by du dx. Where is du dx? Du dx is what? Is 0. Minus sign. And then what do I have? I have u. What is u? U is 1. Multiplied by what? By the v dx. What is the v dx? The v dx is what? Is 2. All over what? Over v squared. Where is v? V is here. So v squared is now going to give me what? 2x minus 3 squared. And now let's finish up the work. Okay, so if you multiply 0 by anything, all this side is going to be 0. And now 1 times 2 is going to give us 2. There's a negative sign there, so negative 2 all over what? 2x minus 3 all squared. Now, I will leave the answer like this, okay? But you can go ahead to expand this and simplify if you so wish to do that. But we can just leave the answer at this. Alright, so this becomes the answer for 2a. Okay, let's look at the 2b. Now, this was the function that we were given. 2b, we have to apply any formula apart from the quotient rule now. So, what do? I can look at the function and say, okay, which formula? When I have this, I can write this simply as this, as 2x minus 3 exponent negative 1. And once I have this, then I can think of a rule I have used before. So I will say, okay, I have inner function, and then I have outside function. So I'll talk about the in function and the out function, and that means that I can apply the what? The chain rule. So if I can apply the chain rule, I will say that I will let u to be equals to 2x minus 3. So this is u. And if this is u, what is now going to be? Then my h of x is now going to be what? U exponent what? Negative 1. So now I have gotten what I want. Now I can find du dx. Du dx here is just going to give me what? 2. And what is now going to be the h du? Okay, so the h du now. And I'm going to differentiate this with respect to what? U. Okay, alright. So the h du is now going to be negative 1. So just say negative u exponent negative 2. Now I have gotten this as well. Let's now apply our chain rule. What is the chain rule? The h, the x is now equals to what? The h, the what? Du. Okay, the h du multiplied by du, the what? The x. So now when I cancel this and this, I'm having what? The h, the x, which is what the h there is. Yeah. So this is now my chain rule. Now let's do the substitution and solve the problem. What is the h du? The h du is now negative u. What is u? U is here, so put it as it is. Exponent what? Negative 2. Multiplied by what? Multiplied by du dx. Every du dx, it is 2. So 2 is there. Now what are we going to get? If I multiply this and this, you can see we have a negative 2. Okay? And then, or say, negative 2 multiplied by what? 2x minus 3 exponent negative 2. Now I want to change the negative exponent and make it positive. So this becomes this. 2x minus 3 squared. And let's see, if you look at what we got before, we can see that when we use the quotient rule, we got exact answer as this. So this becomes the what? The other way in which we can solve this particular what? Problem. Let's look at question number 3. Alright, so this is 3a. And 3a here, we are going to still make use of the quotient rule. So if you want to make use of the quotient rule, we look at this and say, okay, fine. Where is our v? Our v is now 2x minus 5. Our u is 3x minus 2. So that we find the v, the x, and that is giving you 2. And then you find the u, the x, which that is also giving you a 3. Now we have gotten all the terms, so let's do substitution. So our dy dx here, or f prime of x, is now simply going to be v, which is here, 2x minus 5, multiplied by the u dx. The u dx is here, which is 3, and then minus sign, and what we have is what? U, and u is 3x minus 2, multiplied by what? Multiplied by the v dx, and the v dx is what? Is 2. All divided by what? Divided by the v, and the v is by v, and v is what? 2x minus 5 squared. So let's solve this problem. Let's simplify. We multiply this by that, we have 6x minus 15, and these negatives that, so that will also become 6x. This multiply that positive by that will give us what? Positive 4. All over 2x minus 5 squared. Now simplify. This and this is cancelled. 15 and that will have negative 11 divided by what? 2x minus 5 all squared. And that becomes the what? The y, the x of this function that we were given. So now we have gotten negative 11 over 2x minus 5 all squared. Alright, so let's solve 3b, where we're told to find a derivative of this without using the quotient rule. So which means that any other method is allowed except the quotient rule here. So if that is the case, I have to look at the function and see what I can do from here. And when I look at it from this point, I can say that, okay, I can find f of x to be equals to 3x minus 2 into 2x minus 5, okay, exponent negative 1. So I can write this function as this. So this is the same as this. Once I can see from this point, it means that I can see that I can apply the product rule to this. Just learned about the product rule, so we can talk about what? The product rule. Apart from the product rule, again, when I look at this last one, I can see that we can think about looking at it as what? As a chain rule. Because like you can see, there's an inner function and there's an outer function from here. So I can also look at this one as what? As a chain rule from this point. So if that is noted, then I will say that this is u and this is my v, because I want to apply the what? The product rule. But before I apply the product rule, I need to take care of the what? Of the chain rule that I have here. So I am saying that v is now equals to 2x minus 5 exponent negative 1, and from here I will say that, okay, I want, say, my t, okay, to be equals to 2x minus 5, so that my v is now equals to t exponent negative 1. And then from here I can apply the what? The chain rule. So to do that, I am going to find the t, the x, because I'm differentiating t with respect to x here, and that is going to be 2. And from here I need to then differentiate v, okay, with respect to t. So I'm going to look for the v dt, and the v dt is now going to be negative t exponent negative 2. That has become the v dt. Once I have gotten that, the next thing I need to do is to apply the what? The chain rule. And I know for sure that the v, the what? The x here. The x is now going to be the v dt multiplied by dt dx. So that the t will be cancelled and we left with what? dv dx, which is this. And now let's do the substitution from here. So straight away, if I do the substitution, what am I getting there? The v dt is negative t exponent negative 2 multiplied by dt dx is 2. So that is this. And therefore, the v dt will finally become negative 2 dt exponent negative 2, which is negative 2 over what? T is given to us as what? 2x minus 5. So that is what? Sorry. Here this has become positive. Sorry. So that is what? Positive 2. Right. So now this is our what? The v dt. The v dx that we have gotten from here. So I've gotten the v dx. And now from here I have u, I have v. I know that this 2 is what? It's a product rule. So if this is product rule, for me to apply product rule, I also need what? Du, the what? The x. So I need to find du dx from here. So I'm going to find du dx. Remember here, our u is 3x minus 2. And du, the x is now what? 3. So I have gotten the u dx. Let's see. I've gotten the u dx. I have gotten the v dx. I've gotten u. I've gotten what? V. I can apply what? My product rule. What is the product rule? Remember that our product rule is the y, the x, it's now equals to u, the v, the x, multiplied by, sorry, we'll add it to v du dx. This is our product rule. So let's see, we have gotten all the what? The terms that we need. U is here, our dv dx is here, and then v is here, and we know du dx. Du dx, we found du dx, and it is also here. So I can go straight away and do the substitution into this particular formula and solve the problem. So to finalize that, all that I need, I'm going to write it one side, then claim the ones that I don't need now. So let's see the ones that I need. I need u, and I know u is 2x minus 5 exponent negative 1. And I need oh sorry, this is v. Okay. So what is u? My u is 3x minus 2. And what is the u dx? The u, the x, is given to me. It is 3. I calculated for that. And now where is the v dx? The v dx is here. So I can clean the board and do the substitution and complete solving the problem. Okay, so this is the formula that we are going to apply. Which is the what? Which is the product rule. So once I have this, then I will say that the y, the x, is now equals to u, which is 3x minus 2, multiplied by the v dx, and the v dx is negative 2 over 2x minus 5 exponent 2 plus what? Plus v. And what is v? V is 2x minus 5 exponent negative 1. Okay, exponent negative 1 multiplied by what? Du dx. Du dx is 3. So multiply this by 3. Right. I am going to change this into fractions so that the negative exponent will become what? A positive exponent. So to do that, let me just erase this and fix that in there. So then I'll have it as 1 over what? Over 2x, okay, 2x minus 5. Alright, it is exponent just 1, so that is it. Straight away, I've gotten this. Now I need to simplify this problem, and then I finalize that. Okay, let's see this and this. The LCD, or the common denominator for this, is what? Is this. Because this is a factor of this. So if this is the factor of this, I can simply write that as this, all over 2x minus 5 exponent this. And from here, I know that if I express these as that, okay, let's solve them one after the other before any problem. So let's expand this. If I expand this, I'm going to have negative 6x, okay, plus 4 all over 2x minus 5 exponent 2 plus, this is giving you 3 all over 2x minus 5. Now I have gotten this. As I said earlier, this is a factor of this. So if this is a factor of this, I can write a common denominator for all. So to write a common denominator, I am just going to have it as 2x minus 5 exponent 2. And I'm going to multiply each of these fractions by the what? By the denominator. So if I multiply each of them by the common denominator, it means this is going to cancel this out. So we'll be left with just negative 6x plus 4. And here I'm multiplying this whole fraction also by the common denominator. So now we have found the common denominator for this. Okay, sorry for that. There is an equal to sign here. Okay. Now what we need to do is to expand this and simplify. So this will become the y, the x, is now equals to negative 6x plus 4 plus 3 multiplied by this will give you what? 6x, and then positive 3 multiplied by negative 5 will give us what? Negative 15 all over what? Over 2x minus 5 squared. And you can now see the beautiful thing that has come out here. This is negative 6, positive 6, so it will be cancelled. And then we are left with what? Plus 4 minus 15. What would that give you? So we have the y, the x, finally becoming negative 11 all over 2x minus 5 squared. Please, you can always put a negative sign here. Doesn't matter. Okay, yeah, we can put a negative sign here and make it look more beautiful. So this is the what? Is the final answer if we decide to solve the problem without making use of what? The quotient rule. That tells you that it is very important to know all these methods, because you can see when we're solving by quotient rule, it was very easy, straightforward, and then we solve it within a short time. But now you can see that with using this, the product rule and the chain rule combined together, is taking us what? A lot of time to do that, and it makes it what? More tedious in doing that. So it is always good to know all the what? The method in solving a problem, so that once you are given a problem, just select the what? The easiest one to get to the what? The correct answer. And that is the most important thing. Please, if you have not subscribed to my YouTube channel, please don't forget to subscribe to my YouTube channel. And once you subscribe to the YouTube channel, don't forget, click on the notification bell so that anytime I release any new video, you'll be the first person to watch it. I love you. Keep on learning, for learning is life and life is learning. See you next time. Bye-bye.